Assalamualaikum and a very good day to everyone. Okay, so today we are going to make an experiment about energy skate park. There are 4 members of our group. So our objective is procedure, results and discussion. From this, we are going to the simulation. So as we can see here, this is our chart, this is our energy bar. So Faris, what are you going to talk about it?
Okay, so refer for the second refer to the third objective. We want to explain how changing the scatter mass affect energy. Okay, so Arif, can you help me? Can you change the friction to none? Okay, first we will see for the non-friction. Okay, the mass of the skateboarder is 50. Now let's see about the pie chart and the bar chart on how the kinetic and potential energy involved in this experiment. Okay, let's see. So we can see the kinetic energy is indirectly proportional to the potential energy. When the kinetic energy is higher, the potential energy is 0. So we can see the speed. The maximum speed is when the skater on the below of the track. So Arif, can you help me? What is the maximum speed when the skate is at the lower?
10
meter per second. Okay, so how about we change the mass of the skater? How about 100 kg?
This rim speed, which is 10.7, 10.6 meter per second.
So it's slightly higher when the skater is 50 kilogram. Okay, we can see the difference on the bar chart. We can see the total energy that conserved in this simulation is higher before the mass. The skater mass is 50 kilogram. So we know that the bigger mass of someone or object, so the higher the total energy that conserved on the work done. Okay, now can you make the friction half? So from what we get, the speed of the skater will go slowly approach to 0 because they have friction. So the skater will stop at the bottom. So we can see at the bar chart, the total kinetic and potential will be the sum of kinetic and potential will be the sum, and it will be a mechanical energy. So when we add the friction, we can see the thermal energy, the effect on this simulations. So how about we make a lot of friction? Okay, from what I get from this is, the more the friction, the less time taken to the skater to stop. But the kinetic and potential energy before the skate going down, it will be the sum of the 3 energy, that is kinetic, potential and thermal. Now we can see the skater is already stopped, and the thermal is equal to the total is mean the mechanical energy. So we know that kinetic plus potential plus thermal is equal to mechanical energy. Now we move to the discussion. Can you open the slide that we learned in SFT mechanic class?
Okay, as we can see here, so about our discussion, how we can relate from that particular stimulation to our syllabus, which is, as we can see here, kinetic energy we define as Ke equal to half mv square, which is m is equal to the mass and v, which is speed that we got. So as we can see here, so kinetic energy is directly proportional to the mass and velocity, which is if we increasing the mass or the speed, so kinetic energy will increase. How about you, Faris, about potential energy?
Okay, I will explain about the potential energy. We know that potential energy is equal to the mass times gravity times y. Okay, what is y? What is the y is the displacement of the object, where is from the starting point to the end point. So we know when we from the bar chart, we know when the skate is on the below of the track, the potential energy will zero. This is why we take that the y from the below of the track is the initial. And we can see from the lecture note, it turns out not to matter as long as we are consistent about where we choose the y. So from the simulation, we know that the y equal to 0 is at the bottom of the track. So we know that mass and gravitational is directly proportional when the skater is going down, and when you're going up, it's with higher the potential energy. So we go to the conclusion. The first conclusion, we know that mechanical energy is the sum of the potential and kinetic energy in a system. The principle of the conservation of mechanical energy states that the total mechanical energy is a system. Potential, thermal and kinetic remain constant as long as there are only forces acting on the conservative forces. Okay. The second conclusion. The second conclusion, the energy bar and the pie chart show that if an object moves in the opposite direction of a conservation net force, the potential energy will increase, and if the speed of the object changes, the kinetic energy of the object also changes. Other than that, the thermal chart show that the thermal energy getting bigger since the skater go through a specific amount of friction. The bigger the friction of the track, the larger thermal energy produced. The speed of the skater getting lower caused by friction. Okay, Arif, we can continue for the third conclusion.
Okay. Based on our objective, so our third conclusion is if the mass of the skater higher, the potential, thermal, kinetic energy were produced higher. Therefore, changing the mass of the skater will change the potential, thermal and kinetic energy, which will lead to a change in the total energy. Also, for the fourth conclusion, friction is a resistive force to motion. When two bodies move against each other, some of the kinetic energy is converted to the heat energy due to the friction. This reduces the total kinetic energy in the system. Otherwise, the potential energy still remains the same how it's produced. So that's our presentation. So hope you enjoy. Any question? Call us. Assalamualaikum warahmatullahi wabarakatuh.